Here we have a box, but note that despite that it looks like a cube, it is not a cube. It is a rectangular prism with different sides, a height of 6 meters, a width of 4 meters, and a length of 5 meters. The purpose of this exercise is to find the angle of the triangle which is inscribed inside this particular prism. The sides of this triangle are the diagonals on the face of this rectangular prism. Let's look at each face of this prism. If we look at that yellow face and we'll pull it out, we can calculate that diagonal because we know that this side here, or the height, is going to be 6 meters, and we also know that the length of it is 5 meters. We use the Pythagoras theorem to find out what that diagonal is. And we can do this because we have a right-angled triangle here. Now, our Pythagoras theorem says that the diagonal, which we'll call C, can be calculated using this formula here, which can be rewritten as, which is the root of a squared plus b squared, where a can be 5 and b is going to be 6. So c is 5 squared plus 6 squared, and we can then say it's the root of 25 plus 6 sixes is 36, and that is the root of 61. This answer is exact, so there's no need to go into the calculator and find out what root 61 is. It's better to keep it as root 61. And this means that QR is equal to root 61. Now let's have a look at the face, which has a diagonal PR in it, in blue. This face, even though from this perspective it looks like a rhombus, it's not. We can draw it as a rectangle with sides 4 and 5. And this is also a right-angled triangle, and so we'll use, just like above, the Pythagoras theorem. And so by substituting into that formula, we will say that 5 squared plus 4 squared, and that means it's the root of 25 plus 16, which ends up being to the root of 41. Once again, please leave it like this, and we know that PR is, our side is now root 41. So now let's look at our last face with the diagonal of P and Q. Again, our face should be rectangular, so let's draw it as a rectangle. The sides of this rectangle are 6 height and a 4 of width. So we will use the Pythagoras theorem one more time, and we'll calculate that this is going to be the root of 6 squared plus 4 squared. That makes it the root of 36 plus 16, and that should be the root of 52, and we'll leave it as such, and this is going to be PQ. And now that we found out what QR is, one of the sides of the triangle, and PR and PQ, we are going to be able to find the angle PQR. So let's look at this triangle closely. We need to find this particular angle, which is the angle of PQR. As you can see, this is not a right-angled triangle. That means we cannot use the trigonometric ratios, but we can use a rule which is called the cosine rule. So let me introduce you to the cosine rule. This rule can be found in any textbook, maths textbook, or you could look it up online. But the form it is written in is not very useful because I want to find the angle. And in this form, I can only calculate the side. And so I have rearranged it to the form which gives me an angle. The angle is A here. Now, we have an angle of PQR. So let's rename this whole triangle so that we've got ABCs instead of PQR. So the angle A that I want is going to be opposite that side A. And the side B and C could be on either side. Now A was root 41, B was root 52, and C was root 61. And so using the above equation, we can now substitute for A, for this formula, B being 52, so we say 52 squared plus root 61 all squared, take away A, which is root 41 all squared. Now you understand that there was no need for us to calculate the roots because once they're squared, it'll be easy. And all this is over 2b, which is root 52, multiplied by c, which is root 61. This can be simplified to 52 plus 61, take away 41, over 2 root 52 root 61. Which can be now further simplified into 72 divided by 2. I can actually simplify 72 over 2, so that cos A is equal to 36 divided by root 52 times root 61. Now I'm not going to work out this yet on the calculator because what I want to do is find actually the angle A, which means I have to rearrange this to find the inverse of the cos. Now the reason I didn't calculate this form in my calculator because I don't want to transfer decimal points. It will not be as accurate, so I prefer to do it at the last moment on my calculator, which gives us 50.2679, and we can now approximate it to 50.3. That's our angle. And so we have calculated that the angle PQR is equal to 50.3 degrees. I hope you found that useful. So if you did, please subscribe to my channel because that will help me a lot.